Okay, let's jump to 7.6. Alright, so we're going to need little 7.6 to go on to 9.4. Alright, so let's look at this graph. Okay, we're going to introduce two new things here. Well, first let's go over what a normal is. So we're going to talk about the normal line. Okay, and a normal line is defined as a line that's perpendicular to anything, a line, a curve, a surface. Alright, so in this graph here, this BA line is just my line, curve, or surface. It's whatever it is. From the origin that connects it and makes this right angle, this is the normal line. It's some line that I just draw from 0, 0. I hit my line, curve, or surface, and it actually forms a 90-degree angle. So I make this line up here. All right, and this line, that is the normal line. Okay, so that is the normal. All right. So now you'll see the normal has two properties. It has a hypotenuse, a P. All right, so P, where we want to draw this. So P, let's do down here. P equals the length of the normal. Okay, and now we're going to have a new variable, which is just an angle measure. It's called phi. So it's a little circle kind of with a line through the top. All right, and then phi is the angle between the normal and the x-axis. Positive x-axis, actually. Oops, axis. That's positive. That should be x-axis. All right. So, and the reason we're going to 7.6 here is because we want to find this p and this phi. That's our job, right? Once we get that, then on 9.4 we'll be able to use it to actually write equations and stuff. Okay, well this point C is really not the big deal, right? The x and the y, if I want to find this x value here, right? Here's an ordered pair, an x and a y. Well, x is just r cosine, r is the hypotenuse, cosine's the, or phi is the angle. So this is r cosine, sine just like you learned in 9.3, or y like you learned in 9.3, it's just r sine, so here's p sine phi. All right, no big deal. All right. Now, the normal form, right? And this is always a line, right? I'm drawing a line, a normal line. Well, the normal form is written like this. X times cosine phi plus y times sine phi minus p equals 0. All right? So if I got the equations of this line, given the slope and all that stuff, I can rewrite it like this. So this is the standard form now of our normal line. So x, cosine phi, all that good stuff. All right? So it's the standard form of the normal form of the line. It gets kind of tricky. Alright, so let's actually, I didn't have an example here, but let's get an example. Alright, let's find the normal form of, let's say, r equals 2, phi equals 30 degrees. Alright, so if I had this equation, just plug in everything you know. Sorry, not r, p. So p equals 2, phi equals 30. Well, I know it's going to be x cosine 30 plus y sine 30 minus p. So you plug it all in. Alright, so all I did was take my givens. So, and then they're just polar coordinates too, right? A distance and a direction. So I know the length and I know the angle. I can write it out. Alright, well, cosine 30 is, let's see, right through over 2. Alright, if you go from your 30, 60, 90 triangle, sine 30 is a half, and then there you go. So given those two things, I can actually write the standard form of the normal form of a line, right? The line that I just made up to make it perpendicular to my curve, my surface, or my line. All right? Okay, well, that's good, but remember I said we want p and phi, right? I don't want to be given p and phi. If I knew them, I wouldn't have to go through any of this 7.6 stuff. So what I'm going to do, what we're going to do, if you have a standard form of a line, right? So all the stuff on one side, 0 on the other. Now this is different, even though it doesn't look like it, when I actually have the numbers in them. But the normal form is in the same kind of form, right? All the stuff's on the left equals 0. But these numbers are going to be different than these. All right, and my job now is to take this regular linear equation that I'm given and change it into this normal form. All right, so regular linear to normal. All right, how do I do that? I take the term in front of the a, or the x, the term in front of the y, I square them, and then I divide through every single term by that answer. Right? And I choose plus or minus. If it's plus, right, whatever the sign of c is, I take the opposite. So if sign is or c is positive, I'll divide everything through by the negative square root of a squared plus b squared. All right? And if the sign of c is negative, I'll divide through by the positive. All right, so here's just a regular linear equation. I want to change it into my normal form linear equation, because then I'll know what p and phi are. Remember, and again, that's the job. We want to find p and phi. All right, so let's look. Here's just a regular equation. So here's standard form, which is a regular old linear equation. I want to change it to normal form. All right, so good old linear. Well, how do I do it? I first have to find the square root of a squared and b squared, the numbers in front. So I want 2 squared plus 1 squared, square root of 5. All right, so I get the number first. Now I have to determine if it's plus or minus, right? And that's determined by the opposite of this sign. Well, c is negative, so these are going to be plus. All right, so I'm going to divide through now by this a squared plus b squared. So it'll be 2 divided by 5x plus 1. There's a 1 in front of y. Rad 5y minus 5 divided by rad 5. Make sure you divide every term by that a squared plus b squared. All right. And now if we just do our radicals, right? So 2 rad 5, rationalize, that's the word I was looking for. Rationalize your denominators. Multiply by rad 5 over rad 5. Multiply by rad 5 over rad 5. And multiply by rad 5 over rad 5. The 5s will divide out, so I'm just left with rad 5. And now this is the normal form. Okay? So you'll see the tricky part, the tricky part, right? Like it's all just easy. Here's my standard, right, regular or linear equation. Right? Here's my normal form. They look identical in the sense that all the stuff to the left equals 0. But you'll see the numbers are different. Okay? So that's the key here. Standard form, normal form. Alright, it's a little weird. Okay, let's define p and phi now. Alright, so I want to find p and phi. Well, I need to change the normal form to the standard form, and then remember that my normal form is x cosine phi, y sine phi, and then minus p. So with this information, I'll be able to take those pieces now, and then just solve for p and phi. Alright, so you'll see I have the same equation here. Here's the normal, the standard equation, which I had before. Alright, so it's just 2x plus y minus 5, 2x plus y minus 5. So now I know, I'm not going to do all the work again. My normal is simply just 2 rad 5 over 5x plus rad 5 over 5y minus rad 5 equals 0. Okay, so that's my normal form now. Well, also remember that it's cosine phi, right, times x plus sine phi times y minus p equals 0. Right, and that's what I got from up here. I just put the x out front, or in the back, so it could kind of match up. Well, you'll see now, this number is cosine phi. This number is sine phi. This number, right, since the signs match up, is p. Well, that means I know cosine phi equals 2 rad 5 over 5. Right? I know that sine phi equals rad 5 over 5. And I know that p equals rad 5. Well, part of my job was to find p and phi. Well, I just found p. Right from the equation, I know what p is. To find phi, take either one of these and solve for phi. So let's take this one. Phi equals inverse cosine 2 rad 5 over 5. Alright. So now, we go in the calculator. So I'll do inverse cosine 2 rad 5 divided by 5. I get 26.57 degrees. And that's my phi. Alright, so that's how I got P and that's how I got phi. Okay, the last piece, when you do these, just to check. Alright, when I came out, I had a positive X and a positive Y. So I know what quadrant I'm in. I'm in the first quadrant, right? Because it's going to be a positive number times X, a positive number times Y. Alright, my angle came out to be first quadrant, so I'm good. Alright, if the angles are different, then I'm going to have to do my reference angles, get my equal triangles. Alright, and it depends on which one you use. If I use cosine, cosines are equal in the first and fourth, second, third. Sines are equal in the first and second, third, and fourth. So whatever one I use, I'm going to have to use that reference to get my correct quadrant. So just check to make sure positive, positive, that's first. 26 degrees in the first, I'm good. If not, I'd have to use my triangles.